And I'm going to go ahead and share my screen with you. Now with 2009, when I first started doing this problem, I struggled a bit myself to write a full class that would allow me to test my code. But I think I came up with a decent workaround or a decent solution to getting setting up a full class that I would be able to test my solutions. Okay, so let's take a look at 2009. That's 14. Here we go. Okay, so 2009, they give us, almost nothing when it comes to this number cube class. We are told that a statistician is studying sequences of numbers obtained by repeatedly tossing a six-sided number cube. On each side of the number cube is a single number in the range 1 to 6, inclusive, and no number is repeated on the cube. Statistician is particularly interested in runs of numbers. A run occurs when two or more consecutive tosses of the cube produce the same value. For example, in the following sequence of number or cube tosses, there are runs starting at positions 1, 6, 12, and 14. And then it gives us an example of an array with its corresponding index value or position. We then see this a very bare bones class here called number cube with one method called toss. And what the toss method does is it returns an integer value between 1 and 6 inclusive. We then see down below, we're told we're going to write a method called getCubeTosses that takes a number cube and a number of tosses as parameters. The method should return an array of values produced by tossing the number cube the given number of times. Complete method getCubeTosses below. So it's going to return an array of values. We have two parameters, the number cube object and num of tosses. So right away I have a good idea of how to use the num tosses, okay? But I'm not so sure initially how to use the number cube object cube here, all right? So we have these two parameters. So I know we're going to be returning an array of integers. So the first thing I need to do in this method is declare and initialize an array of integers of length num tosses, okay? So I'm going to pull up my Replit account here. And what I did was I created a private instance variable called numSides. And for my constructor for this number cube class, I just had one parameter called sides, which was an integer, and I assigned that to numSides. And then I used that variable to write this toss method, which needs to produce a random number from 1 to 6. So math.random times numSides, which will be 6, of course. So when I create my number cube object in the main class, in the main method, of course I'm going to make it so that it will have 6 sides. So this will be math.random times 6. Cast as an integer will give us a number from 0 to 5, and then we add 1 to that value. I'm going to do this. Actually, I don't think it'll make a difference, but I think the +1 should be outside there. Okay. And that gives us a random integer from 1 to 6. Okay. So that's good. That was good practice for you to try and figure this out, even though it was supposed to be assumed that you knew what the toss method did based on the instructions that were given. Now we have this getCubeTosses method that we were just talking about. So in the very first line of code in this method, we need to declare and initialize the the array, which we're going to call result. You can call it whatever you like. Int, and then the open and close bracket identifies the fact that we have an array of integers here, and we're assigning it to new int num tosses. So this creates the appropriate length of the array. So it has a fixed number of indices that we're going to eventually reassign. So I also have a variable here, sort of a counter variable called tosses, which I've assigned to 0. And in the solution on the AP website, they use a for loop. We can take a look at that solution in a moment. I happen to use a while loop here, so either one would be perfectly fine. While tosses is less than num tosses, that was the variable, or rather the parameter that was given to us. So while that's true, we're going to reassign result at position tosses to cube.toss. Okay? So we take this cube object, dot toss, and it's going to produce a random number from 1 to 6, which will then get assigned at a specific position in the array. We'll increase tosses by 1 so that we can then fill, or reassign rather, the next element in the array. And then finally, when we're finished looping through the array and assigning each position an appropriate value from 1 to 6, we will return the array. Okay? So let's go ahead and test this out. Notice I've declared or instantiated a number cube object, which takes in one parameter, the number of sides. I have an array of integers called result, and number cube, because it's a static method, because getCubeTosses is a static method, I need to use the class name dot the method with the two parameters. So cube1, 18. You can use any number you like. I used 18 because in the example they gave us, there were 18 elements. So I figured I would just be consistent with the problem, or the example that was given in the problem. I then used a loop to print out each individual value that is in the array. If I were to just say system.out print result, I would get that hexadecimal representation of the array. I wouldn't get each individual value. So by having this loop here, and we can go ahead and run the program, we get 18 values between 1 and 6. Okay, so notice my smallest value is 1, my largest is 6. I'm not sure that every value is represented. Let's see, we have 1, 2, 3, 4, 5, 6. So yes, every value from 1 to 6 inclusive is represented here. Okay, and there are 18 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Did I count that right? It might have been off. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Interesting. I got 19. Why did I get 19? It's because I'm starting at 0 to num tosses. Num tosses was 18. So that should just give me 0 through 17 tosses. Let's see if anybody has a comment. No comments? All right, it's not really that important. But it didn't do exactly what I expected. So I'm going to take a look at that later on. But in any case, this is an appropriate solution to part A. Okay? So before we move on to part B, are there any questions? Suppose we can also take a look at the solution they provided. So they happen to use a for loop. Let me just go back to mine again real quick. Let me check. Okay. Yeah, there's nothing different about it except for the fact that I used a while loop and they used a for loop. That was it. In their first line, they assigned an array of integers to have a length that is representative of num tosses. And they use their for loop to loop through the array, which of course will contain all zeros until each one gets reassigned using cube.toss. Okay? And I just might be miscounting, but hold on a second. So if I have 18, I had 18 as my, I have 18 here as my second parameter. Okay. Which means that tosses 0 is less than 18. So it should fill from 0 to 17, which is 18 values. And then from here, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, I'm getting one more value than I expected to, and I'm not exactly sure why. Let me try this, see what happens. Do I get an out of bounds error? Yep. Okay, I got the out of bounds error I expected. Result. Okay, does anybody have any thoughts on why I'm getting an additional, could a for each loop be used? Let me think about that, Kayla, while also reading Tammins. Isn't -1, can you use for each loop as Kayla said? Yeah, I'm gonna have to think about it. Give me a sec, I can think about it 1 sec. For each loop, let's see. No, I don't think you can use a for each loop, okay? If you recall from last week, and this was a multiple choice question on that quiz you took about arrays not long ago, one of the restrictions that we often forget about with for each loops is that the element, right? So you have for each element in the array, that element is a variable. That variable is sort of like a copy of the element at each position, okay? When you're in the body of the for each loop, you're unable to reassign values at specific positions or at any position in the array, in the data structure. So you would not be allowed to use a for each loop, okay? In fact, if we go to the, let's see, do they have 2009? Okay, they had the solutions here. Let's see. We want scoring guidelines. Okay. Let's see if we can find somebody that used a for each loop. I'm just reading what they have here. It doesn't seem to mention anything about the for each loop, but you wouldn't be able to use it for the reasons that I've stated. Okay.
Is that also true if you just refer to it, if you use the temporary variable to refer to it?
Well, let's see. Here, we'll write a new one together. So public static int. We can try it together. Get cube. Here, I'll do it with a lowercase c. Get cube tosses. Number cube int num tosses. Okay, so let's try this together. All right. So let's try this. Right, because when you use the for each loop, the index variable doesn't exist, and thus you're not able to reassign anything at any of the positions in the array. So if you have for each element in the array is an integer. So for each element in the array result, we want to. All right, so here's the problem. This result at position tosses, or which is really the same as result at position index, would be element. But the index variable doesn't exist, so we're not able to reassign anything at a position to some new value. All we would be doing is reassigning element, which is a separate variable, right? The for each loop is really only good for printing things. It's not good for reassigning things in the data structure. And we can illustrate this in just a moment. So element, right? If we were printing something, then these two would be interchangeable. So element is assigned to cube.toss, and we don't need tosses plus plus or anything like that. So return, right? So what am I supposed to say? Return, so each element, see, I'm not even sure, maybe you can tell me if you, I don't know if you were just asking out of curiosity or you actually used the for each loop, right? But okay, so let's say you've assigned each element, okay, to cube.toss. I guess you're returning result, but let's just illustrate what happens here, okay? So let's assume that that's what you wrote. Is this, I'm guessing this is what you wrote. If you wrote something different, you can show me in a second. Let's go to the main method and get rid of this for now. That's for part B. So let's do number cube 2 is assigned to new number cube 6. Okay. And we're going to do this again. Number cube dot get tosses cube 2, comma 18. I'm going to call this result 2. And we'll repeat our for loop here. And I'm fairly certain it's just going to print out a bunch of zeros. Okay. Result 2 at position I. Okay, line 29. Did it work? Hang on, what the heck happened here? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's really weird. That's really, really weird. Oh, because I used, okay, that's why. I had to use a lowercase c there. Try that again. Okay, 1 second. Let's get a system. Here, do this. Do \n. Okay, now we're good to go. Yep, so we can see it's going to be all zeros. We didn't want that to happen. Okay, whatever. But we can see that it's the second array. It's just all zeros here. Okay, it's just all zeros. So when we declare and initialize the array at the start, right, we get an array that's just filled with zeros, and we don't end up ever reassigning any of those positions because that's not something you're able to do with a for each loop. Okay, so no, a for each loop would not have been acceptable there. And part A was worth 4 points. I bet you still would have gotten half credit because you illustrated that you understood that you needed to use, okay, enough of this, that you needed to use a loop. And you had sort of the right idea in place, but that misconception about the for each loop definitely would have, you definitely would have had a point or two off there, right? And we can see that we got zeros. It didn't reassign the elements the way we thought they might. Okay, let's see the comments here. Well, Jay, we're doing it right now. I recommend that we continue to practice problems. That's what I recommend. We have a very narrow focus. We were told that there are going to be 2 questions on the exam. We were told specifically what those 2 questions are going to cover. And we've been preparing for those 2 questions now for the last 4 weeks. So I would say that we continue to practice those types of problems, methods and control structures, arrays, and array list questions. And about a week ago, I wrote on the Google Classroom page a list of the 14 questions you should have practiced before the exam. And my hope, we've done about, I think, 8 or 9 of them at this point. My hope is that we do all 14 together prior to Friday at 4 p.m. Okay? That's what I think. All right. So let's get back to it. Thank you for the question about the for each loop. Hopefully, we understand at this point why we're not able to use a for each loop. All right. So if you have any doubts about when you should use a for each loop and when you shouldn't, I would say that you should only use the for each loop if you're going to be printing values from a data structure. That's albeit an array or an array list. Okay? If you are going to be reassigning values in a data structure like an array or an array list, you're going to want to use either a for loop or a while loop. The reason being is because in order to reassign values in a data structure, you must have access to the index variable that will allow you to do this, okay? So hopefully that is clear. Are there any other questions before we move on to part B? Any other questions before we move on to part B? All right, then moving on to part B. Okay, so this was not easy either. All right, it was just different. And to be perfectly honest with you, I did happen to write a implementation that happened to match the one that was given in the solutions. But for some reason, when I made a call to the method and tried to print the index, I was not able to do so. So maybe you can figure out why, and that would be awesome. But I know that my code is correct. I just haven't been able to, for whatever reason, been able to get it to print the index value. Okay? So let's take a look. We are told that we're going to write the method getLongestRun that takes as its parameter an array of integer values representing a series of number cube tosses. The method returns the starting index in the array of a run of maximum size. So that's a little bit wordy there, and it confused me the first time I read through this. So the first time I read it, I thought, oh, all we have to do is return, because we've done things like this in Practice It. We definitely have had a question or two like this in Practice It before, where you returned, the longest string, or you returned the longest, string of things that happened consecutively within a data structure, like an array or in a list. So I thought, oh, okay, all we have to do is return an integer that represents the maximum run. So for example, 2, 2, 2, and 2 occur the number 2 occurs 4 times in a row, so we're going to be returning the number 4. Okay? That is not correct. What we're doing is we're returning the starting index. We are returning the starting index of the longest run of consecutive numbers within the array. And we're told that we can return either the number 6 or we can return the number 14. The reason being is because the number 5 occurs 4 times in a row starting at position 14. So however you have it set up, it just has to return the index at the starting point of that run of numbers, okay? So if you have 2 runs of equal length, you can return the index of either one. And if there are no runs of any value, so you at no point do you get consecutive values, then you're going to return -1. So it goes into detail about the examples here. Let's just go back up. A run is defined as repeated occurrence of the same value in 2 or more consecutive positions in the array. For example, the following array contains 2 runs of length 4, one starting at index 6 and another starting at index 14. The method may return either of those starting indexes. If there are no runs of any value, the method returns -1. And then they give us our array here, okay? Complete method getLongestRun below. So returns the starting index of a longest run of 2 or more values in array values. Again, returns the starting index. This is why it's important to read this stuff here, the comments that come before the actual method. It tells you what it's going to return, and it tells you what the parameters are in the method. So the param, it says values. Notice how it's in sort of different font. That's the variable that represents this parameter. An array of integer values representing a series of number cube tosses. Precondition values.length is greater than 0. We're going to return the index of a run of maximum size, -1 if there is no run. Okay? All right. See if there are any questions before we, nope, still no Questions? Okay, so back to it. And let's take a look at our method here. Just give Replit a second. Okay. All right, so we need a couple of variables here in order to keep track of things. So my variable names are a little bit different than the ones that were given in the solution, and we can take a look at that momentarily. Let me just go back. Scoring guidelines. No, that's not what I wanted. Here we go. Part A, part B. Okay. So we need an integer variable that represents the current length. Okay, the current length of the run that we are on. So we're going to start with 0 because we don't have a run of numbers to begin with. Okay. Then we're also going to have a variable called longest run. So the current run that we're on may be less than it, and at some point it may be greater than or equal to the longest run that exists. But again, the longest run will be 0 for now as well. Okay. So at some point, the longest run will have to get reassigned to the current run or the current length if the longest run, the current length exceeds the longest run. And then our max size, we're going to initialize to -1. The reason being is because we are going to return -1 if there are no consecutive numbers that match within the array. So we're going to use a for loop here, and it's just a standard for loop header for the most part. But notice that rather than have I as less than values dot length, we have I as less than values dot length -1. The reason that we have this as -1 is because of what we are referencing within the loop. So because we want to check two values that are consecutive within the array, we're going to be using values at I plus 1. And in order to reference values at I plus 1, we at our final iteration through the loop, we are going to be referencing the second to last element, values at I, and we are going to be seeing if that value is equal to the very last element, which will be values at I plus 1, when we've gotten to sort of the far right of the array. Okay, so without the values dot length -1, we would get an array out of bounds exception error. All right, and we can illustrate that by taking away the -1 in a moment. So if values at I equals values at I plus 1, so if two numbers, two consecutive numbers are equal, then we're going to increase the current length by 1. Okay, so we're going to increase the current length by 1. Now, if the current length is greater than the longest run, then we're going to reassign longest run to the current length. And then we're going to reassign max size to I minus current length plus 1. Now remember, max size, which is what we're going to be returning, represents the index of the beginning of that consecutive run of numbers. Okay, so let's go ahead and just run what we have. And I'm going to get rid of this here. So let's just run what we have, and we can see an example. Oh boy. Let's see, this is in the main 16. What do we have? An extra? Okay, we've got an extra bracket. No big deal. Okay, so we have our numbers here, and let's see, 4, 3, 4, 2, 3, 6, 4, 1, 4. So no consecutives yet. 6, 3, 3. Okay, so we have consecutive numbers here, and then we have consecutive threes again. So our longest run is at position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this method should return either 10 or 11, 12, 13. So it should return either 10 or 13 because that's where the longest runs occur. So let's just go back for a moment. Okay, so let's say we get to position, 10. Okay, so I would be 10. 10 minus the current length would be, at that particular time, the current length would be 0 still because we wouldn't have had any consecutive, or I'm sorry, it would be 1 because at that point, no, I'm sorry, if we're at 10, it would still be 0. It's when we get to 11, when we get to index value 11, we would have finally incremented the current length by 1 because we would have at position 10 and at position 11. Okay, so at position 10 and at position 11. So I is in fact 10, I'm sorry. So at position 10 and at position 11, the two values are equal. So the current length will increase by 1, which makes it 1. 1, of course, is greater than 0. The longest run, which is now 1, which is 0, we know is going to get reassigned. So it's going to get reassigned to the current length, which is 1. So longest run now stores 1. And max size is assigned to I minus current length plus 1. Else, the current length is assigned to 0, and then we return max size. Let me just see one thing here. I have a current length plus plus, current length, max length, max, if the current length is greater than the max length, longest run. Okay, so let's go to the main method real quick. And we're going to use this method. So we have an array of integers right here, stored in result. So we are going to use that as our parameter for this method, which takes in an array of integers. Because it's a static method, I have to use the class name dot the method name. So get longest run. So number cube dot get longest run result. And let's try and print that. This is where I was having issues. So let's see if anybody can figure out why it's not returning the index value. Okay. It gave me a 0 there. That's interesting. Give me 1 second. System.out.println. Might have been adding it on to the end, I think is what was happening. Try that again. There we go. Okay, so it is working. So let's see. This is saying that at position 5, at index value 5 represents the beginning of the position where the longest run occurs. So this is position 0, position 1, position 2, position 3, position 4, position 5. So at position 5 marks the beginning of 2 consecutive 4s. Do we have any other runs within the array? We do, but not until much later, and it's 2 1s. Okay, so the way I have it set up, it's always going to be the first one that occurs. Okay, so let's try it again. should be a different result. Notice now it's 6. So let's see, at position 0, 1, 2, 3, 4, 5, 6. At position 6, we have 2 consecutive 2s, and nowhere else in the array after that do we have a longer run of numbers. So it is working. 11. Let's see, so 0, 1, okay? So at the beginning of evaluating this, it's going to store the value 0 because 0 does mark the beginning of a run of numbers that has a length of 2, okay, 2 consecutive numbers. But as we continue on, we get 2 6s in a row, okay, so that's unchanged. Our longest run is still 2. But when we get to position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, when we get to index value 11, we get 3 consecutive 3s, and thus 11 is returned, okay? So that was a good one because it gave us a couple of different runs, and it gave us one that had a length that was more than 2. Let's see the questions here. The max size variable. All right, let's go back. Okay, so the max size variable, I guess we could also call it what are we doing? We're returning the index of the longest run of consecutive integers. So I can call this index if you like as well, okay, which represents the index of the starting location of the longest run of consecutive integers within the array. So I'm going to change this to index. Okay. So for the example that we have here, all right, the first time through the loop, I is 0. Values at position 0 equals values at position I plus 1, because 1 and 1 are equal. So the current length is going to increase by 1. Current length is greater than longest run, which is 0. So 1 is greater than 0, and thus longest run is going to get reassigned to current length. Okay? So longest run now stores the number 1. Okay? Now stores the number 1. And index is going to be reassigned to I at position cur length plus 1. So the current length, which is 1 at the moment, I is 0. So 0 minus 1 gives us -1, plus 1 gives us 0. So 0 represents the index of the longest run that exists at the moment, okay? We come back out, we increment I. I is now 1. So we continue, well, let's just so we'll do this again. So values at position 1 equals values at position 2. That's false, okay? So values at position 1 and gives us back the value 1. Values at position 2 gives us a 5. So those two are not equal to each other. So we don't get to do any of this. Else the current length is now returned to 0. So cur length now returns to 0, and we come back up. We iterate the loop once more, I++. So we go ahead and we check again. Values at position 2. Does the value at position 2 equal the value at position 3? Nope. So we keep, we come to the else. Current length gets reassigned to 0, which it already was. And we keep going through. All right, so we get these 6s, and the same thing is going to happen as it did for the first 2. So let's get to 11, okay? So let's assume now we've gotten to I is 11. Values at position 11 equals values at position 12. That is true. So the current length is now going to increase from 0 to 1. 1 is 1 greater than 1? The answer to that is no, okay? So because it's no, we don't get to do this here, all right? We don't get to do this here, but we come back out and we iterate through the loop once more. So now I is 12, okay? So I at position 12 equals values at position 13. That's true. So the element at position 12 and the element at position 13 are equal. So Kerr length is now 2. 2 is greater than 1. So longest run is going to get reassigned to 2. I minus current length, the current length is 2. So right now we're at I is 12. 12 minus 2 gives us 10, plus 1 gives us 11, okay? So index now stores the number 11. We come back out, we're going to increment again, I++. So now I believe it was just, yes, it was just 12. Okay, so now it's going to be 13. So I at position 13 equals values at position 14. Let's see. So that's 11, 12, 13. So the element at position 13 does not equal the element at position 14, and thus we do not enter the conditional here. None of these lines of code gets executed. Okay, so the current length goes back to 0. We finish it off. Index stores the number 11, and we return the number 11. Okay, we return the number 11. So the max size, a better name for it is just index, which represents the position of the starting location of the consecutive number of values that are mapped, that are the same from one position to the next. Okay. All right. So we've been together for about 50 minutes today. I think that's enough for today. What I would like to do is meet up again tomorrow. I'm supposed to meet with my freshman computer science, but we can push that off. And I would like to meet again tomorrow at noon. And it'll be much quicker, and we will go over the 2014 question, which has to do with strings. So we really haven't talked much about strings in a while, so this will be a good question for us to practice. If you're feeling a bit rusty with strings, I would encourage you to go back into chapter 3 in APCS Awesome and just practice, or maybe it wasn't unit 3. Where was the string stuff? Maybe it was unit 2. Yeah, so unit like 2.6, all this stuff with strings and using the string methods. Let me see exactly where all that stuff was. So string methods 2.7. So I'd go back into 2.7 and really familiarize myself with the methods of a string class, especially the substring method, index of method. Those are really, really important and could certainly pop up in either one of the FRQs, even though you may not have you may have assumed that because we were dealing with arrays or because we were dealing with array lists or the methods and control structures, that the strings may not appear. All right, but that's not the case. So we'll take about probably 20, 25 minutes tomorrow. That's it. And we'll go over 2014 number. We will have a test. Who has a test around? You have a test around 2 p.m. tomorrow? What do we have? Calculus tomorrow? Okay, so would you rather do it earlier in the morning than noon?